Hello, grade 11. We were in chapter 6, generalities about functions. We said that in this chapter we recognize intervals in R, we define function and its representative curve, and then define parity and symmetry of a function. Uh, we talked about functions or about intervals in R, that every function, its domain of definition is an interval in R. Many kinds of intervals, closed interval in this case, open interval, semi-open interval to the right, semi-open interval to the left, semi-closed interval to the right, semi-open interval to the right, and so on. These kinds of intervals, just to know their names. We said that a function f of a set E is a set F is a relation where every element in E admits an image in F. Any element in E admits an image in F. يعني any X admits an image Y, okay, and any X have a unique Y or has a unique Y, just one Y. We said that the set of elements of E having an image by F forms the domain of definition of F, and it's called dF. Okay, so if dF is not given, we have to find it. So we said that the function or a type of relation where there is exactly one output for every input. Okay, for every X there is exactly one Y, only one Y. This kind, or in this case, this x, which is 1, has two y's, 6 and 7, so it's not a function. First one. The second one, it is a function since every x has a unique y, but this y may have two x's, it's okay, but every x should have only one y. It should not go to two numbers or two y's. We talked about vertical line test. If we have a graph and we draw a vertical line as this green line here, it's parallel to the y-axis, and we move it along the function. If it hit the function in 2 points, or the curve in 2 points, so we say that it's not a function. If it hits only at 1 point for every line we move it here, so it is a function. Parity and symmetry of a function. We said that parity of a function parity of a function f is said to be even if for every x belongs to the domain of definition minus x belongs to the domain of definition f of minus x equals f of x. And when we say parity of a function, so it may be even or odd. Okay, sometimes يكون neither, it's okay, but when we talk about parity يعني even أو odd. Okay, so even f minus x equal f of x, and the y-axis is the axis of symmetry of this function, and odd f of minus x equal minus f of x, and in this case O is called the center of symmetry of this curve. That case. So even function having y-axis as an axis of symmetry, odd function has the origin is the center of symmetry. As in this example, it's an even function. This example is an odd example, odd function. And we said, sorry, we said that to test the function if it is an even or odd, find f of minus x, as in this case, and compare it at the end with the original function. If it is the same, with the same size, so بيكون هذا الفانكشن even. Okay. In this case, we found f of minus x, and we got that it is the same but with opposite signs, so it is odd function. If it's not the same sign, not opposite signs, so we will say that it's neither odd nor even. Sometimes some functions are neither odd nor even. Symmetry, we say that a line x equal a is an axis of symmetry if the domain of definition is centered at a and if f of 2a minus x equals to f of x, or every x belongs to the domain of definition, and this we may find it by calculation. In this case, x equal a بيكونوا axis of symmetry like that. Okay, x equal a is an axis of symmetry. It divided into two equal parts. To prove that center I, AB is center of symmetry, if and only if the domain of definition is centered at A and f of 2a minus x plus f of x equals to b, and also we may find it by calculations. In that case, I is center of symmetry, it would be like that. That's everything. Thank you.